Hello, my name is Mr. Fontenot. Welcome to my YouTube channel, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I'll be calculating the values for a purely capacitive series circuit from the Chapter 17 math handout, problem number 1. We see here my known values that I am taking from the Chapter 17 math handout, problem number 1. I'll put a link in the video description below so that you can print a copy of this math handout. And I'll also be using the Chapter 17 formula handout. And you see that I've got the appropriate formulas copied and pasted to our sheet where we can see them here. Alright, so I've got 24 volts, AC, 400 ohms, 800 ohms, and 1.2 k ohms. And we see here that this is XCT, XC1, XC2. And XC stands for capacitive reactance of opposition to current flow that we have with a capacitor measured in ohms. Alright, so the first thing I'm going to do is find my total capacitive reactance. We see formula number 3 here. We just simply add them up. So 400 ohms plus 800 ohms plus 1.2 k ohms gives me 2.4 k ohms. Inside of the parentheses here, I can use Ohm's law. So I've got 24 volts and 2.4 k ohms of capacitive reactance. This gives me 10 milliamps. If I look at current in a series capacitive circuit, current stays the same, so I can fill them all in, 10 milliamps. Again, I can use Ohm's law inside these parentheses, so 10 milliamps times 400 ohms gives me 4 volts, 10 milliamps times 800 ohms, 8 volts, 10 milliamps times 1.2 k ohms is 12 volts. Now I have to find the value of each one of my capacitors measured in farads. So I'm going to use formula number 11. C equals 1 over 2 pi f xc. So I'm going to hit 1 over under 2 shift pi times my frequency, which I'll get from my math handout. And we see here that it's 318.3 hertz. It's just hertz, not kilohertz. Times XC, 2.4 times 10 to the third. Hit engineering, and this gives me the value of my capacitance, but I want all of these answers in microfarads. So you're going to hit shift engineering to convert it to microfarads, and this gives me 0.208 microfarads. Again, the way I got that, you hit equals, you hit engineering, it's in nano, we want it in micro, so we're going to hit shift engineering. The value of the capacitors must be in microfarads. So that gave me total capacitance. If I want to find the value of C1, I'm going to use XC1. So I'll go up here, and the only thing I'm going to change is the value of resistance. Of capacitive reactance. So I'll leave my frequency in there, 318 times 400, my new capacitive reactance value. Hit engineering. All right, that one's in microfarads, 1.25 microfarads. Next, I want to find the value of C2, so I'm going to put in the value of XC2. I'm going to change the 400 here to an 800. Get rid of the 4, put in the 8, so now I've got 800, hit equals, hit engineering. You see that it's in nano, so I've got to change it to micro, hit shift engineering, 0.625 microfarads. Finally, I want C3, so I got to change the 800 to the value of XC3, which is 1.2K times 1.2 times 10 to the third. Engineering, all right, it's in nano, so I got to hit shift engineering to put it in micro. 0.417 microfarads. I'm taking this number here and rounding this number. Yeah, in this case, I'm going 3 numbers after the decimal. 0.417 microfarads. And here are the values that I'm looking for on the Chapter 17 Math Handout Canvas Answer Sheet assignment found on the Chapter 17 module of your Canvas page. Thank you.